So in today's video, we'll be talking about the named pipes in Windows. So these named pipes are used for inter-process communication. That means two processes can communicate with each other using these pipes, and these processes can be on the remote system as well. So the server process will create a pipe. So in this we will call the server as the server instance and the client as the client instance. The server can create or connect to an existing pipe, named pipe. So after connecting, we need to wait for any receiver or the client instance to read or write to this pipe. If there is no client instance that is going to read or write to this pipe, then our program will be in the blocked mode. So that means our program will not continue and will infinitely wait for any clients to connect to this one and do the operations. So first we have to create a pipe using the create named pipe function. After that we need to connect to this pipe, and then the operations should be like sequential manner. If this is the write operation, this should be read operation, and vice versa. So this pipe now can act as a shared medium for both of these processes. So this is the function create named pipe a function, and it creates an instance of named pipe and returns a handle for subsequent pipe operations. So let's copy this one. This will create a named pipe, and if the named pipe exists, the server our server process will connect to that pipe. It will not connect to the pipe, it will create a server instance so that we can connect and do the operations. So if you search for WinAPI Rust, go to this documentation and now search for this one, and here you can see we have the WinBase. So we are using the ASCII functions. So now let's go and create two programs. I have already created this one. So the server instance is called named pipes, and I have already imported this one, user mode named pipe API and WinBase. So we are going to use this WinBase module for the functions. So let's first create a pipe. So let's also see the arguments parameters. So the first one is pipe name, and the pipe name is of the format // dot. So this dot is indicating the computer name. This can also be the IP address, but whenever we are creating a pipe, we cannot create on the remote computers. It should be on only local computers. The clients can connect to the remote pipes by placing the IP address instead of this dot. So whenever we are using this function create named pipe a, then the dot only should be there. It will not accept the IP addresses, and the pipe and slash the pipe name, and the open mode. So in which type of mode we want to open. So pipe access duplex, this allows bidirectional data transfer, and inbound means the client can write to the server. So in inbound, the client can only write to the server, and the server can only read the data from this pipe. And in the outbound, the server can write to the client, and client can only read the content. So we'll be using the pipe access duplex for bidirectional data transfer. So this file flag overlap will be used for multi-threading. So we can also create multiple server instances and multiple client instances. Now maximum instances. So the maximum number of instances that can be created for this pipe are 255. So you can create 255 server instances for one particular named pipe. And output buffer size and the input buffer size. So these are the buffers to read and write to. And the default timeout. So default timeout is 50 milliseconds. And the next one is security attributes. Will be passing null. So let's go and create our named pipe. Create and the name of the pipe. So let's say ret. So you cannot use the raw strings here. I have used the raw strings and it did not create any pipe. So to escape one backward slash, we need to use another backward slash. So there are 4 backward slash for 2 values. And then we want to say dot for the current computer and pipe and then my pipe name. So the pipe name should not contain backward slashes. We can say tech69. Let's go and pass this to this one. So my pipe dot as string, as pointer, sorry. As constant i8, and the open mode is duplex. Copy this, and the pipe mode is so we missed this one, pipe message. So we will be writing the stream of messages and maximum instances. So let's say 2. So buffer sizes, sorry, previously I thought the buffer sizes. So let's say 1024 and 1024. And the default timeout 0 and security attributes null. Now we have created our pipe. Now we need to connect to this pipe using the connect named pipe function. So enables a named pipe server process to wait for client process to connect to an instance of named pipe. So we'll be waiting forever for the client to connect to our pipe, and then the client can connects using the create file or call named pipe function. So let's copy this and pass in the, so we will get the pipe handle as the return value. Let's say server pipe. Pass the server pipe into this function, and this one is 0. We did not use flag overlapped in the previous values. Let result. So now we are going to write the client instance. We'll be using the create file here. So this will create a file or create a client pipe instance. So the first parameter is file name. So the file name can also be the pipe name. And the desired access. So we want to read write, and the shared mode will pass the 0 and security attributes null, and creation disposition open existing. So open the pipe, it only exists. So let's write this. So create file A. So let's copy this pipe name and paste here. So my pipe dot as pointer as constant i8, and desired access is generic read. So if you import these named pipe API or the members, you will also have the generic write and generic read. So these are just constant values. So if you hold control and click on this, you will get to this page and you can see here the values. So you don't need to search for values, you can just directly write these constant values. And the creation disposition is open existing, that value is 3. And flag attributes, these are for files. So let's pass the value 0, and the last one is this parameter can also be null, so pass this one. Now we have connected to the pipe. Okay, so this is client pipe. Sorry, now we can do the operations. Here let's do the write operation. Let mute in buffer. So let's create 2 arrays, in buffer and out buffer. So copy this. So first we want to write the content to the pipe. So write file function, it will take the file handle or the pipe handle, and the buffer number of bytes to write and the number of bytes written. So let's say write file A. Okay, just the write file, and we need to pass the pipe handle, that is server pipe, and the buffer. So we can use buffer, or we can just say hello world dot as bytes dot as pointer as constant c void. Yes, this should do. So you don't need to use separate buffers, it will be good to use separate buffers. So number of bytes to write, so we can say hello world. So copy these up to as bytes, and we can say as bytes dot length. And number of bytes written, so we don't need to care about how many bytes we have written, and overlap, that is 0. So we need to pass the pointer to overlapper structure if we opened the pipe with this attribute flag file flag overlap. So let's pass this null. As u32, I guess. Yes. Now we have written the content, we need to read that content from the pipe. So read file, pass this pipe handle, and the read into this in buffer dot as mute pointer as mute c void, and number of bytes to read is this one. So copy this, or we can say 1024. So we need to it is always better way to read exact bytes, otherwise in one function, in impersonating the client's token, we'll be waiting forever to receive all the bytes. So here this hello world is not even 20 bytes, but we have specified 1024 bytes to read. So in the future videos we'll be seeing the impersonating the client's token. So in that video, since we have specified 1024, the server process will wait forever to receive these remaining 1024 bytes. So that's why it's always better way to specify the exact bytes to read. So copy this and paste here, and number of bytes read, again we don't want to get that value, or you can also get that value as well. So declare a variable let mute bytes read is equals to 0, then you pass that mutable reference in this function. Now we have successfully read the contents. Now we can go and print these values. So we are converting this into string from UTF-8 lossy and pass in the in buffer reference. We can also trim these the null bytes at the end. Now we are good to go. So let's go and try to run our program. So cargo run release. So let's open this in CMD. So let's first run we need to create the pipe, so let's run our server instance program. So here we can see the program is waiting for any client to connect to that pipe. So let's go and run this. So I think the client did not connect, so let's see what went wrong. Let's put this 0. So here we can see I forgot that null byte at the end of the pipe name. So here we can see the output hello world. Now you can also read from this server instance when there is a write operation in this client instance. So we can also do that as well. So I'm going to copy this one, copy, and change this pipe handler to the client pipe. So received hello world from server. So we are writing the content. So okay, we are good to go now. Let's copy this read operation and let's paste this in our server instance. Change this to server pipe. So you can do this from arrays, storing the strings, converting the strings into an arrays, but I'm just showing for the demonstration. So after writing the file, what you can do is you can flush the buffer. So flush file buffer. So we need to pass server pipe so that we don't get any extra characters. Suppose if you have read 100 characters and the next one next operation is the write operation with only 20 bytes, then there will be chunk of 80 bytes. So we need to flush that as well. So let's run this. Here we can see received hello world from server. So this is how named pipes work in Windows. So let's recap what we have done in this video. First, we have created a named pipe using the create named pipe a function. So this will create a named pipe or will create a server instance if the pipe is already existing. Then we need to connect to that pipe and wait for the any clients to actually do the operation. So we will be using this function connect named pipe. If there is no client, we will be waiting in the infinite time, and then the client connects to the pipe using the create file function, and after that we can do the operations like reading and write too. So that's all for this video, named pipes. In the next video we'll be seeing how to impersonate the connected clients token using the another impersonate API.